Hello, dear students of plus 2 medical, non-medical. First of all, welcome you all on my YouTube channel, Physics Concepts and Motivational Talks. उम्मीद है सारे खुश होवोगे, अपनी पढ़ाई वधिया तरीके नाल कर रहे होवोगे। पढ़ाई करते करते कई चैलेंजेस आते हैं, कई बारी आपां नूं मुश्किलां भी आउंदियां, लेकिन जे तुहानूं अपना विजन क्लीयर है, तुसीं कोई मुश्किल कोई भी चैलेंज नूं पार कर सकते हो। कहते विजन जे होना चाहिए तो बाज वर्गा होना चाहिए। बाज अपना टारगेट अपना शिकार कई किलोमीटर तो देख लेंदा है, उद तक वो नज़र रखता है जो तक वो शिकार कर नहीं लेंदा। सो विजन अपना बाज वर्गा रखो, दूरदर्शी रखो, तुसीं जरूर कामयाब होंगे और तुहाडे सपने सारे पूरे होंगे। सो अज का टॉपिक है अपना एप्लीकेशंस ऑफ कूलम्स लॉ in vector form and dielectric constant. So first of all, we have to find electrostatic force due to a line charge distribution. That is, if we have a charged wire and we have to find electrostatic force at any point, at any test charge Q, to the whole wire which is charged, using Coulomb's line vector form. Simply suppose AB be a line charge distribution, OB any point, reference point, origin, Q be a test charge where we have to find total electrostatic force due to this line charge AB. Let R vector is equal to position vector of test charge Q and R dash is the position vector of small element of length dl of the line charge AB. Let lambda R dash linear charge density, that is charge per unit length of the wire, because charge per unit length of the wire may be given, then we can find total charge on the wire. Then small amount of charge on the small element of length dl at location R dash is given by dq is equal to lambda R dash into dl, charge per unit length into length. So this means, because Coulomb's law is true for point charges, for small point charges, then by using Coulomb's law in vector form, electrostatic force due to the small element of length dl, or you can say due to small charge dq at q is given by df is equal to 1 upon 4 pi epsilon naught q dq, product of charges q dq, r minus r dash over r minus r dash mod q. This is vector form of Coulomb's law. Therefore, total electrostatic force F is given by q upon 4 pi epsilon naught line integral A to B. Because this wire is made up of large number of small elements and it is a continuous charge distribution. Therefore, we take line integral A to B instead of summation. It is a continuous charge distribution. We take summation where there is discrete charge distribution. So total force will be F is equal to, vector F is equal to q upon 4 pi epsilon naught line integral A to B lambda r dash instead of dq lambda r dash dl r minus r dash over जो ऊपर लिखे हैं r minus r dash mod q. This expression gives the electrostatic force due to a line charge distribution at a point. So very easy, only two steps are involved. First is small amount of charge you have to calculate, which is lambda r dash dl, then total force. Similarly, we can find force due to a surface charge distribution. If there is a charge surface S, by simply making few changes, same expression, same everything, you have to make some changes to remember. So instead of dl, we are taking ds, the small area element at location r dash, q, same test charge at location r. Then instead of lambda r dash, linear charge density, that is charge per unit length of the wire, here we are taking sigma r dash. This is surface charge density, that is charge per unit surface area. charge per unit area is called surface charge density. Then again small amount of charge due to the small area element ds is given by sigma dash into ds. Instead of lambda we have sigma, instead of dl we have ds. So it will be sigma r dash into ds. So small force will be, instead of q we have q dq sigma r dash into ds. Everything is same. Simply change lambda r dash to sigma r dash and dl to ds. So total force is given by q upon 4 pi epsilon naught. Here we have surface integral over the entire surface. So sigma r dash ds r minus r dash upon r minus r dash mod. So this is electrostatic force due to linear charge distribution. This is total electrostatic force due to surface charge distribution. And third is force due to volume charge distribution. Similar, suppose we have volume charge distribution V. Again, let dV is a small volume at location r dash, q same at location r. Now instead of lambda r dash or sigma r dash, we are taking rho r dash. Rho r dash is the volume charge distribution, that is charge per unit volume of the given volume charge distribution. Then instead of lambda r dash dl or sigma r dash ds, we have rho r dash dv. Instead of single integral, here we have double integral, triple integral. So over the entire volume, so we have total force F is equal to q upon 4 pi epsilon naught rho r dash dv upon into r minus r dash upon r minus r dash mod q. So we have calculated three electrostatic forces: line charge distribution, surface charge distribution, and volume charge distribution. So no confusion, you have to just understand, and we have to take only change the charge distribution. In linear charge distribution it is lambda r dash, in surface charge distribution it is sigma r dash, and in volume charge distribution it is rho r dash. So rho r dash is volume charge distribution, charge per unit volume. Sigma r dash is the surface charge distribution, charge per unit volume, and lambda r dash is the linear charge density in linear charge distribution. So we can calculate electrostatic force due to line charge, surface charge, and volume charge distribution, that is continuous charge distribution, using Coulomb's line vector form. Now what is dielectric constant? So dielectric constant may be defined as the ratio of permittivity of medium to permittivity of free space. It is also called relative permittivity. So it is noted by epsilon r or k, capital K. So or epsilon is equal to epsilon naught k. Where epsilon naught is the permittivity of free space, its value is constant 8.85 into 10 to the minus 12 SI units. And this epsilon depends upon nature of the medium in which the charges are situated. So to find expression for K in terms of electrostatic force, let 2-point charges Q1, Q2 separated by distance R. Suppose first they are placed in free space or vacuum, whose permittivity is epsilon naught. Then electrostatic force between these 2-point charges in free space or vacuum is given by F naught is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, equation number 1. Magnitude of force by Coulomb's law again. Now suppose the same two charges Q1 Q2 separated by same distance R, but now they are placed in a medium of permittivity epsilon instead of epsilon naught. Now they are placed in a medium. Then electrostatic force Fm is given by 1 upon 4 pi. Instead of epsilon naught we will have epsilon or epsilon naught k, Q1 Q2 upon R square. This is electrostatic force when charges are placed in a medium of permittivity epsilon or dielectric constant k. Now when 1 divided by 2, so we have everything cancels, we have F naught upon Fm is equal to k. It means dielectric constant of a medium is defined as the electrostatic force between 2-point charges separated by a certain distance placed in free space or vacuum to the electrostatic force between the same 2-point charges separated by same distance but in the medium. So this is known as the electric constant of a medium. This means electric force, electrostatic force is inversely proportional to electric constant. So more is the electric constant of medium, more is the electrostatic force. So for dielectrics, its value is finite. For example, for water, its value is 81. So K has finite value for dielectrics, electric medium, and for free space or vacuum, the value of K is taken to be 1, because epsilon is equal to epsilon naught and K is equal to 1. And for conductors, the value of K, that is dielectric constant, is infinite. You can remember for short as type questions. So value of K for conductors is infinite, and for free space it is 1. So we can also calculate dimensional formula for epsilon naught from the same Coulomb's law. So epsilon naught will be equal to Q1 Q2 upon 4 pi r square into force denominator. So substitute the value of charge in terms of dimensions, because charge is equal to current into time. So we write A into T. So Q1 Q2 will be A square T square. Length square will be L square, because 4 pi has no units. Force M1 L1 T minus 2. If we simplify it, we have epsilon is equal to dimensional formula of epsilon naught will be M minus 1 L minus 3 A2 T4 within square bracket. So sometimes you may be asked to derive or obtain dimensional formula of epsilon naught. So this is all about Coulomb's line vector form and its applications to find electric force due to a continuous charge distribution, and concept of dielectric constant, and how electrostatic force varies with the dielectric constant. So this is all about first chapter, electrostatics, electric charges and Coulomb's law. In the next video, I will discuss electric field, very very important topic. So stay tuned till next video. Be happy and बस हौली हौली फिजिक्स ਨੂੰ ਇੰਜੋਏ ਕਰਦੇ ਹੋਏ ਪੜ੍ਹਦੇ ਜਾਓ। ਇੱਕ ਦਿਨ ਆਓ ਤੁਹਾਨੂੰ ਫਿਜ਼ਿਕਸ ਬਹੁਤ ਸਿੰਪਲ ਔਰ ਸੌਖੀ ਲੱਗਣੀ ਸ਼ੁਰੂ ਹੋਗੀ। So be happy.